Hello, everyone. Welcome to the last talks before the closing. I'm very pleased to welcome Ergon Kronenberg, an UX architect from Ergon Informatik, here with us. And he will talk to us about how user experience can have some critical impacts in the real world and in critical applications. And I hope you all have fun, and I hope you have fun as well.
Thank you very much. Hello, everyone. My name is Ergon. As introduced, I work as a UX architect with Ergon Informatik. Ergon is a Swiss leader developing Switzerland's most user-friendly solutions. We empower smart people with smart software. The title, Aviation and UX, what we can learn from aviation incidents to improve the usability of our products. What do tire bomber pilots, an overstretched air traffic controller, and the things that you can stick to the top of your pencil have to do with user experience design? For the next 30 minutes or so, I'll try to show how important it is to take the human nature and the human cognition into account. The agenda, there will be a short introduction. Then I'll show you what human factors is. Then we'll take a closer look at what happened in Überlingen. And after that, I'll show a few insights with you. I will go through. At the end, there will be a short time for questions and answers. We build software for humans, and humans make mistakes. But nobody summed it up much more eloquently than Goethe did. So we will adopt his words as the unofficial theme of this presentation. A few words before we take off. Why this topic? I grew up in a small town with a little airstrip, so I was interested in aviation from a very young age. And that passion for aviation just grew exponentially when I was working as a brand designer in the brand agency for Swiss International Airlines. So you will hang out at the airport a lot. You will get a lot of kerosene into your nose. And I was part of the team that conceived and executed the new plane livery for Swiss. And my work culminated in the first Boeing 777 that was delivered to Swiss. And the company dedicated that plane to all of its employees. So I had the idea to put on portrait images of the employees on that plane. So you might ask, what does that have to do with user experience? More than you think. Actually, the answer to this lies at the very beginning of a discipline that we call UX design today. So let me introduce you to the science of human factors. Let's go back 80 years during World War II. And during that time, there were huge innovations in aviation leading up to and during the 1940s. During that time, the airspeed of an aircraft would increase by 300%, and the number of controls a pilot would find in his cockpit would increase by about 350%. As complexity increased, so did the number of accidents. As the pilots were blamed, these accidents were called pilot errors. And one series of accidents raised particular questions. It was a series of accidents with the Boeing B-17F, also called the Flying Fortress. Here she is. It's the year 1942. Europe was occupied by the Nazis. The Allies were still years away of retaking their territory on the ground, so the war was moved to the air. Bombers take off from England, fly out over the coast, and attack targets in Germany. On their way, they are greeted by heavy anti-aircraft fire, so this is what a typical day at the office for a bomber pilot will look like. And now you can imagine the state those pilots were in as they made their way back to England, to their base. So there was this series of accidents. Actually, it was a series of more than 400 accidents, all of the same type. So the pilots, on their approach before landing, instead of moving out the gear, they moved it in again. Very, very peculiar. And they should have had, instead, moved out the flaps. And the flaps is a part of the wing that helps you lose speed. It's like something like an air brake. So back at the time, a B-17 cost about $250,000 to build. Adjusted for inflation, that's around $3.7 million today. So those 400 accidents alone cost damage of some 1.5 billion US dollars. The Air Force was not happy. They tasked a young psychologist called Alphonse Chapanis. He was quite young at the time, 25, and Chapanis did a study. He visited the planes, he took a look at the cockpits, and he was conducting a series of interviews with the pilots. Soon he found out what the cause of the failure was. It was a poorly designed control panel. The controls for the flaps and for the gear were of the same shape. And at the same time, and that didn't help, those controls were in close proximity to each other. Here's a picture of it. To the left, you'll see the control for the gear, and to the right, you'll see the control for the flaps. At least to me, this looks like a recipe for disaster. So, what Chapanis did, he devised an ingenious solution to that could be implemented very quickly. After all, it was wartime. You couldn't fly all those planes back to their factory. Fitting a small rubber wheel to the end of the landing gear switch, which you can see to the left, and a small wing-shaped thing at the tip of the flap switch, like things you can stick at the end of your pencil. Very easy. I'll go through, so questions at the end, please. Following that modification, there were no further accidents as a consequence of confusing the two switches. And after the end of the war, this tactile aid to distinguishing the two controls can be found in every aircraft today. So to the left, you'll see the gears switch, and to the right, you'll see the flap switch. We call this technique shape coding. This is the situation in the cockpit. Up to the right, you'll see the gear switch, and down, you'll see the flap switch in safe distance of each other. The work of Alphonse Chapanis was based on research. And back in the days, as a graphic designer, I would say research is the foundation of solid design. Today, working in the software industry, I would rather say research is the foundation of solid systems engineering. The work of Alphonse Chapanis made a shift in thinking, because what was earlier on called pilot errors was called design errors or engineering errors after. The quintessence of Chapanis' work was humans do not have to adapt to technology. Rather, the technology must be built and designed to take the human nature and cognition into account. And that was the dawn of a science we call human factors. So this science still exists. It deals in the interplay between humans and technology. It takes into account the design of equipment and devices, often in close collaboration with industrial designers. It's about the adaptation of the working environment, and it deals in adjustment to processes. In general, it's the application of cognitive and behavioral psychology. From the perspective of human factors, organizations are called socio, technical systems. Quite an interesting term, isn't it? For those of us who are sometimes very focused on a specific task, function, screen, solution, this definition from the field of human factors invites us to look up and take in a broader perspective. This objective is very much the same as we have in UX design. Actually, human factors can be considered some kind of root discipline of user experience design. Before we move on to the next chapter, I'll introduce you to a model. We call it the Shackle model. And Shackle proposed not only to take the user, the task, and the tool into account, but also take a broader look at the environment, the context. And there we go. Software is always used in a specific context. And that said, let's dive into what happened in Überlingen. In the late evening of July 1st, 2002, two aircraft collide in an airspace that's almost empty. How come? There was little traffic and no sign at all of anything unusual that night. To explain that, here's a screen of the sky over Europe at the beginning of March. And you can detect here like a pattern, and many planes fly behind each other like they were driving on a road. And actually, we call those air routes. As a plane, you have to follow a certain flight path. Here we can see the flight paths and the air routes of the two planes that were colliding that night. Vertically, the airspace is also divided into layers. We call these flight levels. So here we go. Flight levels allow many planes to cross each other's paths in a safe distance. And at last, there is the aircraft accident report. On the first pages of that report, it states the sole aim of the investigation is to prevent future accidents in the occurrences. The investigation took 2 years, and the report was published in May 2004. Thomas Anthony, the director of the Aviation Safety and Security Program at the University of Southern California, said, "There may be one thing that's obvious, one primary thing, but there is never one thing." And so does the aircraft accident report distinct between direct causes and systemic causes. That was the case in Überlingen too. Überlingen was an accident waiting to happen. The stage was set for an accident long before the two aircraft collided. The air traffic control room was short-staffed. The telephone system's emergency link was poorly maintained, and maintenance work in general was badly coordinated. These are just 3 examples of factors that in isolation do not hold the potential for an accident. But in combination, however, they created a situation that clearly was a decisive factor. The sequence of events that resulted in the accident, they took place over roughly half an hour. You can see that illustrated by the bar to the bottom. It all starts at 10 minutes past 9 when the air traffic controller is left alone in the control room. That was kind of company policy. Very bad idea. 3 minutes later, the radar system goes into fallback mode. And what that means, I'll get into that later. Some 8 minutes later, a cargo plane enters the airspace and reports on flight level 320. Then, a few minutes later, something happens that nobody did expect. They expected like a quiet night, low traffic, and now there is this passenger flight that's delayed, and it must be cleared for landing. Shortly after that, the cargo plane asks for permission to climb up to flight level 360. This is a very common practice because the higher you fly, the less fuel your airplane would consume. So they climb, and exactly 3 minutes later, they reach flight level 360. They do not report this. As far as I know, they don't have to, but it would have certainly helped. Shortly after, another passenger aircraft enters the airspace at flight level 360 as well. The air traffic controller does not realize that the two aircraft now are on a collision course. During the next 5 minutes, the controller is fully consumed with the landing clearance for the delayed passenger flight. And that is exactly what he has to do, because there's one golden rule if you're an air traffic controller. If you have several planes and one of those planes has to land or is about to land, you have to really focus and concentrate on that plane alone. You have to invest all your resources on that plane, because the approach and the landing is one of the most critical phases in a flight, like the start, and most accidents happen in those phases. At 33 minutes past 9, the passenger aircraft gets a TCAS notification. So something happens. Can the accident still be averted? I have to open a parenthesis here. What is TCAS? TCAS is short for Traffic Alert and Collision Avoidance System. And it's a system that is installed in every commercial aircraft. If two aircraft are on a collision course, they would pick up each other's radar signals. And as soon as that happens, the devices would calculate the flight path and devise a resolution. And this conflict resolution is very easy. No complicated maneuvers, just climb for one plane and sink for the other plane. No bank, no curve, no maneuver, just climb or sink. Easy as that. Again, 33 minutes past 9, the passenger aircraft gets a TCAS notification, and they are disturbed by that, so they forget to report this either. So the air traffic controller does not know this. A minute later, this TCAS notification escalates to a TCAS alert in both aircraft. Now is the time that the air traffic controller gets it, that something is off. He orders the passenger aircraft to descend to a lower altitude, giving, without knowing, a conflicting order to the TCAS. Shortly after that, the cargo plane obeys what the TCAS says and starts to descend, because they are the ones who get the descending order, and they do what TCAS says. So they reacted correctly. What we have now is two aircrafts descending on a collision course. One step back. Let's take the Shackle model. And Shackle proposes to take the environment into account. So on one hand, we have the cockpit of the Russian plane, the Tupolev, 5 men in this cockpit. And number one, the seat number 1 is the pilot. He was flying the aircraft. And besides him, there was an instructor. And the instructor had the role of the pilot in command. So the pilot would fly, and the pilot in command would give the commands. And that was an instructor. So maybe it's a little bit hard to argue if the one giving orders is an instructor. Not so easy. The crew of the aircraft of the Tupolev have to deal with conflicting orders. And from the voice recorder, we know that they started to discuss, and it escalated to some kind of an argument. And in the end, the crew decided to obey the air traffic controller's orders and to sink, in contrary to what the TCAS had said. And no wonder here, because in the training and in the documentation materials, this TCAS system always was considered some kind of a backup device. So for them, it was just logical to follow the air traffic controller's orders and to rather ignore the orders of the TCAS. On the other hand, we have the control room as an environment. Let's take a look at that. In the control room, the air traffic controller is alone. Back at the time, they called that single-manned operation, which is a beautiful name for a very shitty idea. He has 3 functions. He must monitor 2 radar displays. He must monitor 2 different radio frequencies at the same time. And for all that, he must roll back and forth between the 2 terminals. To me, that looks like a pretty hostile working environment. At 35 minutes past 9, an alarm sounds in the control room. It's an acoustic warning. It's normally accompanied by a visual warning signal as well, but today is not normal because the radar system is in fallback mode, in maintenance mode. And in fallback mode, there are no visual alerts. Can the accident still be averted? The air traffic controller does not notice the alarm because he doesn't expect it. And I will get to that later. He simply doesn't hear it. So it comes that on the night of the 1st July 2002, at 30 minutes after 9, 2 aircraft collide at flight level 340, around 11,000 meters above the small town of Überlingen. There is a huge bang that sounds like rolling thunder, and the debris is spread across an area of 30 square kilometers. There are no survivors on either aircraft. By some miracle, nobody on the ground is hurt. The aircraft accident for Überlingen stated, the scope of conscious human attention is limited, and if this limited attention is divided between several demanding tasks, it is impossible to continuously analyze all of the incoming information in detail. So this is a hint on how perception works. Perception is a combination of objective external information and subjective information drawn from memory. Where our attention is divided, we tend to perceive what we expect to perceive, and in other words, we tend to not notice what we don't expect to notice, or what is unfamiliar to us. The word perception comes from the Latin word percipere, and it means to grasp or understand. Here you can see roughly how perception or visual perception works. We have an object, this triangle here. The triangle reflects light. Light goes through the lens, falls on the back of the eye, where optical nerves transform the incoming light into impulses. The impulses get transmitted to the brain, and the brain forms the image. So we can see it's both a physiological and a psychological process. Important. Human perception functions in exactly the same way, whether you are an expert or whether you are a lay person. There is no such thing as an expert perception. And why do I say this? Probably in the course of your career, you will hear the sentence, that's expert software. The user experience doesn't have to be so great. That's not true. Seriously, folks, that's bullshit. because experts are human too, and humans have their cognitive limits. Experts also need to have information presented in a digestible way, even more so than in consumer software. Expert applications need to offer fast, intuitive, and reliable access to different courses of action. And if there's one measurement at all, it's not expertness, it should rather be impact. Impact on what happens when somebody makes a mistake. Kim Vicente, the author of the book The Human Factor, writes, in complex systems like nuclear power, healthcare, or aviation, cognitive engineering can make all the difference between life and death. Vicente coins in the term cognitive engineering. And a good example is the autopilot in an Airbus aircraft, where you transfer the control from the pilot to the plane by pushing in a button, and you transfer the control from the plane to you as a pilot by pulling the button. Cliff Quang says you have to know why people behave as they do and design around their foibles and limitations. That brings us to the idea of human-centered design over and again. It should be obvious, right? We are not designing software for oranges, snakes, or cherry blossom. Nope, we don't, but the idea of human-centered software engineering has been around for quite a while. It's a fixed term under the ISO standard 9241-210, in which the term expert appears precisely once. It contains processes for designing usable interactive systems and principles of human-centered design. At this point, I'd like to offer you 4 takeaways. Perception is both a physiological and psychological process. Some things in human perception are hardwired. We can't change that. We have no leverage there, but we do have leverage how software is designed and can take that into account. Humans built themselves a mental model based on knowledge and assumptions, and if we design software, we better take into account those mental models. Technology must adapt to human behaviors, never the other way around, and particularly important to me, software and systems are always used in a particular context, and we need to know that context. That can be done by user research, is something that a UX designer or a UX researcher offers. There are methods like conducting interviews or conducting a contextual inquiry, where you go there and observe the users at the place of their work in their environment. It's elaborate, but it's definitely worth the investment. So here are the 3 E's. You have to engage with your users, examine what they do, possibly at the place of their work, and establish a profound knowledge of their tasks. We in the software industry can get tied up really in the theoretical. Sometimes we think we can solve the world's problems from behind our desk, but we can and must do more. We need to go where it happens. So one principle is genba or gemba. It's the Japanese verb for where it happens. And the principle behind gemba is to engage with what is happening, where it's happening. It's from lean production. I think it was established by Toyota, I guess. A short anecdote here. A customer once said to me, "It's great that you're solving the problem at this point, but it's not where it's coming from. It comes way back in the process." And I blushed. In fact, I got red like a tomato because I exactly knew he was right. And just 1/2 day of on-site research would have made that clear to everyone involved in the project. If you happen to work with Lean UX, a principle established by Jeff Gotthelf and Josh Seiden, they have their own word for it. It's GOOP, which is short for Get Out of the Building. Again, software is used in a context, like here. or here. We need to be interested in that context, because this is what we owe to the people who use our software. Thanks.
Thank you very much, Ergon, for a very insightful talk. And now we have time for Q&A. Does anyone have any questions? Yes.
I want to ask about the B-17s you mentioned. You said that it's had a lot of impact as cost on the government. Were all of the 400 accidents, did all of them result in unrepairable aircraft, or?
Good questions. I don't know that exactly. I even read that at one source was writing about even 450 of them, but I'm unsure. I know it's really 400 for sure. I guess not all aircraft were damaged, but I have seen a series of images where they really land like on their belly without the landing gear out. So I must assume that the major part of them was really destroyed.
Thank you.
Any other questions? Yes.
I have a question about the aviation regulation in place in the year 2002. If you're a pilot today and you fly westerly, you're only able to use the odd or the even flight levels. And if you're flying easterly, I think you're only allowed to use the odd flight levels. Which plane was on the wrong flight level, or wasn't the regulation in place at this time?
From my knowledge, I think that regulation concerning the flight levels was already there in place. And the accident report stated that they call it, I have to look up, the direct cause was like that the two planes came too close. So, I mean, they probably wouldn't have crossed, but because of the fact that both of them were sinking, of course, they were soon on the same flight level on a collision course. I mean, they crossed each other like not exactly on 90 degrees, but they would have had different flight paths. But due to the fact that they were both sinking, they just collided.
So they weren't both on flight level 360 initially, because they're like 1,000 feet apart. Okay.
Yes.
Thank you.
So from this, what you've explained was what has been learned from the accident with these military airplanes. So what has been learned from the incident or the accident of Überlingen, or how have now the system, or has the system changed, and how that things like that never happen again?
Okay. From the aviation perspective, what has been learned is that they discovered that the Russians, in particular, or maybe not all of the airline companies, did the same regulation regarding the TCAS systems. Clearly, the Russians, they were instructed to have this system in place, but for them it was like something like a proposal. If your TCAS would give you an alert, it was more or less like a proposal. And after that, as a consequence, it was stated that every plane that gets a TCAS notification or a TCAS alert must obey the TCAS, regardless of whatever somebody else says, air traffic control, your captain, regardless of what different information you might have, you always have to follow the TCAS orders. And on the ground, I think this single-manned operations was stopped soon afterwards, because that was clearly too much for one person to handle. I think those were the two main learnings from the accident.
Thank you. Any more questions?
I actually don't have a question. I just want to say that I think the presentation design was absolutely immaculate. I really liked it.
Thanks. Merci.
Any questions? If not, I have one. In the end, you mentioned some attitudes certain developers have towards UX, and you as a UX architect, you probably encounter them regularly. Or if you do, how do you deal with them and convince them to do better UX?
Not easy, I have to confess. Sometimes it's not even the engineers. Sometimes, yes. But at some occasions, it's rather the client who has a strict budget, and then you propose something like UX research, and to them, it's something strange, or they don't see like the benefit of it right away. And then you really have to convince them, because like research is always an important part. And if we are, as designers, as UX designers, if the more information we have about the context where the software is used, the better the solution gets, clearly. Sometimes you would visit the users at their workplace, and you see things that they would never tell you in an interview. You could phone them, and they could tell you what they do the whole day long, and you would never notice that they look up something on their mobile phone but it's work-related, and they don't use the computer for that. Some really strange things happen on the workplace that you would never discover. So the main work is to convince engineers and customers alike of the benefit of conducting UX research, like interviews or a contextual inquiry.
Does anyone else have a question? Microphone disconnected. But does anyone else have a question? If not, then I'm only left to... Oh, sorry. I didn't see you there. You.
Thank you. In my experience with UX design, there's a bit like two conflicting things, because you talked a lot about, or how you mentioned it, it's mostly there's a system in place, and then you do the research about that system, and you change it afterwards. But what I experience is that the end user sometimes doesn't really care about a good system. He just wants it to be the same as it was last time. And so you have those conflicting things between you have to have a better system in theory, because we humans act like this and that. But there's already a system in place, and the user knows how things work. Maybe it's not that good, but he knows how it works. And so how do you handle that in practice? Because I think it's not that easy.
No, it's actually not that easy at all. Sometimes people get really used to their workflows, and it might be the shittiest workflow on earth, but still they're used, and we always underestimate the power of what you're used to. So little people like change their mobile providers just because it's easy. And it's the same at the workplace and the workflows people use. And sometimes you would like make a workshop with them, and or you would visit them at their workplace, and then you devise together with them. And that's the key, the collaboration between the clients and the people involved with you as a UX designer. I couldn't come with any solution. I really have to ask them, and sometimes it's in close collaboration with them to draw something up, And that might be extremely easy, like a sketch, or like if you work in Miro together, you could like sketch things out, and at some point they really get it that there could be something better or improved, and that's the point where they get the point that they have the chance to change things. But as you said, it sometimes really takes a while, maybe one workshop or two. I once had a client who was very workshop averse. They thought it was wasted time, and we invited them, and I made some wireframes before of the things I thought. I created the model, an assumption, a hypothesis of this workflow could flow. It was a very easy wireframe in Miro. And then I talked them through and then told me, it could be nice, or no, we don't work that way. And there was a 1 hour break. And in that 1 hour break, I changed the wireframe to what they said. And after that, we could build on that. And after that first workshop, he told me, at the next workshop, I'll be on vacation, but I really want to be in that workshop as well. So if you can convince that they have the chance and to have their say, and sometimes they see things and get the point that their workflow can be changed. And sometimes it really takes a while, and until you have all the users on the new system.
Thank you.
I'm curious about one of the slides. There was a slide, if you could go back to it, with an engine of an airplane, and the first word was engage, I think. There were 3 keywords.
Second, probably. Where was it?
It's not too far back, probably a few more slides. It was before the key takeaways. There were 3 keywords.
Or these 3 E's with
with the 3 E's.
That's way back, actually. Here.
Oh, yes, here.
Yeah.
Is it intentional that it's a photo of an airplane engine because you think about the word engine and you correlate it with the others? I mean, it looks like a technique for the presentation.
Originally, that would be like a line that I would like to say that those activities could give your project like a boost. So a boost of knowledge. If you engage and examine what's happening, and this boosts your knowledge about what your users do. You really have to get out and take a look at what they do.
That's interesting. Thank you.
Thanks.
Any more questions? Well, call out if I have my back towards you, but I think this time you're really done. So all I'm left with is to thank you again and share a little token of gratitude with you.
Thank you very much.
Thank you very much for this very informing talk. And yes, now all that's left is to enjoy the closing and have one more applause for Urban, of course.
Thanks. Okay.
So the closing will take place at 4:40 in the Audimax. So it's 1 floor up, all the way in the middle. You basically can't miss it. There are also signs. So yeah, see you there.